Hey everyone, this is Dr. Walker. This is video 503 on the vector product, also known as the cross product. The vector product is a different type of product between two vectors that gives us a vector as an answer rather than a scalar. A cross product is notated with the little X symbol to find the cross product of two vectors, such as A and B. To find the magnitude of that cross product, we do AB sine of theta. So you can see in this picture we have two vectors A and B, and this is the cross product, A cross B, which is vector C. To find the length of this vector, it's AB sine theta, where theta is the angle between A and B. And vectors have a direction. The direction of the cross product is perpendicular to the plane formed by A and B. The plane formed by A and B is shown by this disk, and vector C is perpendicular. Now, vector negative C is also perpendicular, so how do we know which way the cross product goes? That's going to be for the next slide, but first I want you to think about this. For cross product, think of how perpendicular vectors are. When vectors are very perpendicular to each other, then they will have the highest cross product possible. But when they're not, they will have a low cross product. So it's kind of opposite to the dot product if you think of it that way. The dot product from the previous video showed us more how parallel two vectors were. Okay, so how do we find the direction of the cross product? We use the right-hand rule. It's a three-step process. What you do is you point your fingers along the direction of A. So you could have your fingers here, right here, your four fingers here, a straight line pointing along direction A. But then what you have to do is you have to curl or fold your fingers towards B. So your fingers were pointing towards A, but now you are folding them this way. So I always learn to fold the fingers, so you're folding them this way. This picture curls them, whatever you prefer, but I had them straight along A, and I just folded them towards myself, towards B. When you do that, then your thumb is going to point towards C, where C is the cross product. So you see that in order to fold my fingers towards B, towards me, my fingers had to point up, right? If I had my thumb going downward, my thumb was going downward, my fingers were going here, and then I would have to fold them away from me, right? And that is not the way B is pointing. B was pointing towards me, not away from me. Please note that in order to use this right-hand rule, you must use your right hand. If you use your left hand, it's not going to work. So you point your fingers along the first vector, you fold in the direction of the second vector, and your thumb will point along the direction of the cross product. We will see this rule when we're dealing with cross products, such as when we're dealing with torque, which will come up later this semester. And we'll also see it a lot in Physics 2 when we're talking about the magnetic force. Let's look at some properties of the vector product. If your vectors are parallel to each other, then their cross product is going to be 0. And that's because we know that the magnitude of the cross product, right, the magnitude of the cross product is AB sine theta. When vectors are parallel to each other, theta is 0, sine of 0 is 0, and so the whole cross product is 0. So two vectors crossed to themselves, that will equal 0. However, when you have orthogonal or perpendicular vectors, then their cross product is going to be AB, which is the maximum possible value for the cross product, right? Remember that the value of sine of theta is equal to 1 or less. So this is the maximum value when you have sine of 90, which is equal to 1. And when they're parallel, you have the minimum value when sine of 0 is 0. So if we extend this to the unit vectors, if we cross parallel unit vectors such as I cross I or J cross J or K cross K, we get 0 when we cross a unit vector with itself. But if we cross orthogonal unit vectors, then we get the following identities. I cross J is equal to K, J cross K is equal to I, and K cross I is equal to J. Notice in the middle here that if we flip the order of the cross product, then we have to add a negative sign to get the same thing. So what this means, if you have I cross J, you get K hat, but if you have J cross I, you get negative K. And even though I didn't make a big announcement of it, we did see that in the picture here, that we had A cross B with C going up, but when we did B cross A, then we had negative C going down, so in the opposite direction, which adds a negative. So using these identities, whenever you do a cross product, you should be able to figure out the direction of that cross product. If you don't have these memorized, and the way I've memorized it is I just remember the order IJK, so IJK, and then now you're at J, well what goes after J is K, and so you get I, and then what comes after K is I, then you get J. So the three properties here follow the order IJK. But if you ever don't know what the direction of the cross product is, you can always use the right-hand rule. So let's say you're trying to do, let's say I cross K, for instance. I cross K. Well, you're going to put your fingers in the direction of I. So you have your fingers over here. And then you have to fold them in the direction of K. So your fingers are pointing right, your thumb has to point down so that you can fold your fingers in this way towards K. And so your thumb here is pointing down. And your thumb is the cross product, so that means that I cross K is equal to negative J, just in case you do need to figure it out using the right-hand rule. Let's look at some examples in the video that follows.